believe this will let you go forward or backwards. It's on. I'm sorry. I should have tested that.
Hello. This presentation is aimed to introduce you our laboratory directed by Maurizio Forte and the main ongoing projects of the digital archaeology we have undertaken. The name Dig at Lab recalls the main goal of this research lab, which is digging for information, looking for new interpretation at the intersection of archaeology, cybernetics, heritage, computer science, cognitive science, art and history. More specifically, we are interested in investigating how the information is shaped, elaborated, stored, and then culturally transmitted by different societies with a focus on ancient civilization. We like to say that the past cannot be reconstructed, but simulated, and then performed by digital simulations. Maybe. Can I?
Yeah. There we go.
A quick look to our equipment and the general workflow. We usually start from data collection in the field, working at different scales, artifacts, architecture, sites and landscape. We are equipped with several instruments, laser scanners, camera, total stations, etc. Others will join shortly, those in gray, particularly a drone. Then we use a wide range of software for data processing and eventually some devices for stereoscopic visualization like Oculus Rift and Z-Space. At Höyük you can also find the dive, a stereoscopic rear projected room, 3 meters per side, with head and hand tracking and real-time computer graphics.
Try.
This is an example.
Oh, I'm sorry. What's that? Okay.
Now let's take a look at the major ongoing projects. Regium at Lepidi 2200 project aims to commemorate the anniversary of the Roman foundation of Regium Emilia in Italy, founded at the behest of Marcus Aemilius Lepidus in 185 BC. The project seeks to evoke the ancient Roman city from the past by analyzing the surviving archaeological clues. As a result, a multimedia room will be set up inside the Musei Civici of Reggio, in which visitors can experience stereoscopic real-time visualization devices like Oculus Z-Space, interactive touch screens. As a first step, we started collecting and digitizing the available archaeological drawings, and we entered these pieces of information into a GIS database. For instance, in this case, red dots represent ancient floor findings, and the red lines the hypothetical Roman street grid of the ancient city. You can see how the Roman street grid still partially matches the present urban tissue. Maybe you cannot see because of the red. Okay, no problem. We also purchased the next slide. We also purchased very useful LiDAR data from the Italian Ministry of Environment. This is a digital surface model of Reggio. And the next is the corresponding digital terrain model with a spatial resolution about 1 meter. On the other hand, we carry out a number of new digital acquisition of artifacts preserved at the local museum. The models were generated through structure from motion techniques. In this case, we use Egisoft PhotoScan. As you can see, it was quite tricky because the items were located in difficult areas, not accessible. So we used stairs and other. We generated very dense 3D polygonal meshes of Roman mosaics to represent visceral geometric details. In the next slide you can see, in the bottom right image you can see the polygonal mesh without color information, so you can appreciate the 3D details in this part of the. This is what the result of this acquisition. And the frames, about 80 frames were needed to generate this high detailed model of the mosaic. Also freestanding artifacts like this Roman tombstone. This is a screenshot from PhotoScan. We also carry out a laser scanner survey around the foundation of some huge buildings discovered in the basement of Credito Emiliano Bank and originally belonged to the forum area of Regium. We placed we placed many different targets, spherical targets and also checkboard targets around the foundation in order to align each scan and to georeference the models. And then the architectural reconstruction that was based on architectural fragments. In this case, these elements were created using PhotoScan, the capital, piece of the cornice, the ceiling, and the rest was cloned using the original patterns. Also because classical architecture is very regular, made of modules, so you can repeat it. Particular thanks to Vitruvius criteria, you can reconstruct an entire building starting from single pieces. In this case, we had also the foundation possibly. And the image in the center and lower, you can see the original foundation overimposed to the reconstruction, 3D reconstruction of a temple. The next. Dense 3D polygonal meshes are not suitable for real-time visualization, so we exploited computer graphic techniques, mostly used in computer game development, in order to optimize the model without losing the decorative details. Among these are a level of details, occlusion culling, normal and parallax mapping. So we can preserve small details, mapping them onto a simple geometric model as a texture. This is the pipeline in order to create these simplified models. In the next slide, we can see an example showing how a LiDAR digital surface model of Regium can be reused to quickly generate a 3D model of the city by extruding a surface and projecting a color ortho image onto it. And then, differently, the ancient digital terrain model was generated modifying the present DTM by removing modern artifacts like elevated roads, embankments and canals, assuming that the natural landscape underwent very little changes. The major modifications are mainly anthropogenic. The original ground level of the ancient city, up to 4 meters lower than the present, was generated by interpolating both archaeological and geological elevation data relating to the Roman phases. And the central image, purple dots corresponds to the core samples and blue dots to the archaeological finds. GIS features, points, lines and polygons, as well as the modified DTM, were imported into procedural modeling software, CityEngine, in order to generate the city blocks and the residential lots in an almost automatic way. These 3D models were created according to some given building rules and small assets of libraries, models and textures, so that repetition are avoided, yet the number of prefab items is limited. And that's the final result after importing the models in Unity 3D, another software we used. So you can see the landscape with the sea, the forum area, and the metropolis, industrial area also here. Okay. And this is Oculus Rift development kit 1 and 2 that will be used to explore the ancient city in a very immersive, stereoscopic way. This is a walk-through view, in particular the right eye, because it's stereoscopic, so you are actually inside the scene. The field of view is more than 90 degrees horizontal, and resolution is 1280 by 800 pixels. The image, as you can see, is barrel distorted, that is then corrected by lenses in the headsets. So generating a spherical mapped image for each eye. Vulci 3000 project started last year with the preliminary season on the Etruscan archaeological site of Vulci in Italy. The project aims to investigate both the ancient urban context and the ancient landscape appearance through different remote sensing and geophysics techniques. We have already collected and organized some data in a GIS database, vector feature relating to the archaeological interpretation of clues, mostly crop marks from aerial imagery, and raster images, orthophotos, elevation data from LiDAR survey, as you can see on the right image. Oblique aerial photos featuring crop marks that prove very useful in order to retrace buried structure still to be archaeologically investigated. You can see almost all this part is still to be investigated, and in particular periods of the year you can see the footprints of this buried structure. We don't know anything else about it, so it's an important clue. In the next slide, you can see how oblique images were rectified in air photo software before being imported into the GIS database. You can see here these shapes relating to the oblique photos after rectification. We carry out also a laser scanner survey, the Silver Hands 2. This is a screenshot taken from PhotoScan 3D, featuring all the scans after alignment. You can see the underground chambers of the tube here. This is the ground. This is a point cloud of the scans. Another short movie recorded through the point cloud generated by the laser scanner. So this is the surface. You can see some targets we placed, particular spherical targets, because they are recognizable from any different position. scanning of body. That's one. These are the chambers, the underground chambers. Now the tomb is under restoration, so there are some scaffoldings all around. Another spherical target. Okay. Instead, these images refer to the magnetometer survey carried out in some areas of Höyük. Output data have proved very noisy due to the volcanic soil, yet some features are visible, possibly another smaller tumulus on the, if you press exactly there is possibly there is another tomb. In collaboration with a specialized team, we carry out a drone survey for generating high-resolution digital models of the entire site. You can see here on the right image the model and also the mesh without color. You can see some features emerging from the ground, still to be investigated. The last project is another archaeological context. We are in Çatal, Höyük, a Neolithic site in Turkey, in which structure from motion techniques have been massively applied in order to provide a 3D digital record of the archaeological excavations. Last one is another short movie. Since digging in many cases implies a destructive approach, 3D documentation becomes more and more an essential way to preserve a thorough archaeological record, phase by phase. All these models have been georeferenced with the aid of small targets and a total station, so that one can virtually re-excavate the site for a better interpretation. This is particularly meaningful considering that traditional archaeology methods of representation are very subjective, and that many pieces of information are lost since excavation is a repeatable event process. Thank you.
Are there any questions?
I had a question. There was kind of a slide earlier that had some sort of pattern that was on the wall, and you showed the pattern and then the relief of that.
Mm-hmm.
That's not exaggerated, is that the actual relief? Or?
The actual, you mean the mosaic?
Yes.
Yeah.
Yeah.
Actually, it's not exaggerated. It's the real. If I can go back, maybe. It was a kind of experiment because we noticed some differences between the reality because black tesserae are displaced in some way.
Yeah.
That's it. So as you can see, black tesserae are deeper.
Yeah.
So it's not properly a real representation. There are some issues to understand and to correct maybe, but it was a sort of trial experiment.
Right.
But the detail, the mesh is very dense, of course. And,
So this was done with the laser. This was laser scan.
no, this is structure for motion, or it means from digital photos we can reconstruct the entire photogrammetry, not properly, but more or less, or computer vision techniques. The software was PhotoScan. It's very powerful tool. Used also for landscape reconstruction.
Gotcha.
So multi-scale approach. Yeah. Actually, we are still evaluating the software because the previous example was made by another team. So I'm not sure about the software they use, but we can even use PhotoScan, or another software I used was PhotoMode. Both are Russian software, Regium.
Thank you.
Thank you.